In this second episode on the topic of indefinite integrals, we are going to evaluate integrals which have trigonometric functions as our integrand. So let's recall that the derivative of sine x is cosine x, the derivative of tangent x is secant squared x, the derivative of secant x is secant x tangent x, the derivative of cosine is minus sine x, the derivative of cotangent x is minus cosecant squared x, and the derivative of cosecant is actually minus cosecant x cotangent x. Now, if we are going to integrate cosine x dx, this will give us back our original function sine x. So this will be our first integration rule. Integral of cosine x dx is actually sine x. Similarly, if you take the integral of secant squared x dx, this will give us tangent x. If you're going to integrate secant x tangent x dx, this will give us secant x. And if you're going to integrate sine x, this will be minus cosine x. The integral of cosecant squared x will be minus cotangent x, and the integral of cosecant x cotangent x will be minus cosecant x. Now in each case we add a constant c. Let's take our first example. So we have integral of 4 cosine x dx. As you have seen in our first episode, if you have a constant inside the integrand multiplied to a function, you can move that constant outside. So this will be 4 multiplied by integral of cosine x dx. And from our formula, recall that the integral of cosine x dx is just sine x plus a constant. So this would be equal to 4. The integral of cosine x will be sine x, and we add a constant afterwards. For letter B, we have integral of 2 tangent x minus 5 secant x. This function is multiplied by another function secant x dx. So first we multiply secant x to each term. So this would be integral of 2 secant x tangent x minus 5 secant squared x dx. And as you have seen in the first episode, if you have f plus g or f minus g, you will have to get the integral of each term. So we have integral of 2 secant x tangent x dx minus integral of 5 secant squared x dx, and we can move the constant outside. 2 integral of secant x tangent x dx minus 5, we can also move the 5 outside of the integral, so this will be integral of secant squared x dx. Recall that if you have integral of secant squared x dx, this will be tangent x plus c. We will use this here. And also integral of secant x tangent x dx is actually secant x plus c. So using these two formulas, we will have 2. This integral will be secant x minus 5. The integral of secant squared x dx will be tangent x, and we just add the constant c. Let's continue with our second example. So we have for letter A, integral of x plus 3 sine x dx. You can split this integral into two integrals. So this will be integral of x dx plus 3 integral of sine x dx. I already moved the 3 outside of the integral. And we will get here for the first integral, we can use power rule. We just add 1 to the power, so this will be x squared over 2 plus 3. Well, the integral of sine x, recall, the integral of sine x dx is actually minus cosine x plus c. So we will have minus cosine x plus a constant c. Rewriting this one, we will get x squared over 2 minus 3 cosine x plus a constant c. For letter B, the integral of 1 plus cosine x over 1 minus cosine x dx cannot be integrated right away. So what we do is to first rewrite the integrand using an identity, where the identity will actually be integrable using our integration rules. So note, 1 plus cosine x divided by 1 minus cosine x is equal to 1 plus cosine x divided by 1 minus cosine x. We can multiply this expression by 1 plus cosine x divided by 1 plus cosine x. Actually, this is just 1, so we are just multiplying the original given by 1. 1 plus cosine x times 1 plus cosine x will actually give us 1 plus 2 cosine x plus cosine squared x divided by 1 minus cosine x times 1 plus cosine x. This will be equal to 1 minus cosine squared x. Recall that we have sine squared x plus cosine squared x is equal to 1. So if we have 1 minus cosine squared x, so this will just be sine squared x. So this expression now can be written as 1 plus 2 cosine x plus cosine squared x, and the denominator now can be replaced by sine squared x. And since there are 3 terms, we can split this into 3 fractions. So this will be 1 over sine squared x, 2 cosine x divided by sine squared x, and cosine squared x divided by sine squared x. So we can actually rewrite this further. 1 over sine squared x is cosecant squared x, plus we can rewrite this one as 2 times 1 over sine x times cosine x over sine x, plus cosine squared divided by sine squared x is actually cotangent squared x, and this will be cosecant squared x plus 2. 1 over sine x will be cosecant x. Cosine x divided by sine x is cotangent x. We can rewrite this last term as cosecant squared x minus 1. And finally, we can combine like terms. So this will be 2 cosecant squared x plus 2 cosecant x cotangent x minus 1. Now, our original integrand 1 plus cosine x divided by 1 minus cosine x can be replaced by this identity. So for letter B now, the integral of 1 plus cosine x divided by 1 minus cosine x dx, this can be written as integral of, we are going to use this identity, 2 cosecant squared x plus 2 cosecant x cotangent x minus 1 dx. Now we have to integrate each of the 3 terms. This will be 2 of the integral of cosecant squared x dx plus 2 integral of cosecant x cotangent x dx minus integral of 1 dx or integral of dx. So ultimately we will get integral of cosecant squared. Remember, integral of cosecant squared x dx is equal to minus cotangent x plus c. Also, integral of cosecant x cotangent x dx is equal to minus cosecant x plus c. So using these formulas, we will have 2 integral of cosecant squared x dx is just minus cotangent x, so we can put the minus before the 2, and this will be 2 integral of cosecant x cotangent x dx is minus cosecant x, so we'll put the minus before the 2, cosecant x. Integral of dx is actually x, so this will be minus x plus c.